question is whether two service entrance cables, each servicing a 100 amps meter, can be run in a single 2-inch conduit for protection as they pass through a wall. The answer, based on the National Electrical Code, specifically Article 338.12b, is no. This code section addresses uses not permitted for service entrance cable and directs you to calculate the required conduit size based on cable cross-sectional area and percentage fill as specified in NEC Table 1. To determine the correct conduit size, firstly, you must calculate the total cross-sectional area of the cables. The example provided assumes 1/0 AWG aluminum cable, which has a cross-sectional area of 1,526 square inches. If your cable size is different, you will need to obtain the correct cross-sectional area from cable manufacturer's data or appropriate tables. Secondly, multiply the individual cable cross-sectional area by the number of cables. In this case, 1,526 square inches times 2 equals 3,125 square inches. This is the total area occupied by the cables within the conduit. Thirdly, consult NEC Table 1 for conduit fill requirements. This table specifies the maximum percentage of the conduit's interior area that can be occupied by conductors or cables. For conduits containing 4 or more conductors, the maximum fill percentage is 40%. This 40% fill requirement is in place to allow for adequate heat dissipation and to prevent damage to the conductors during installation and operation. Fourthly, divide the total cross-sectional area of the cables by the maximum fill percentage to determine the required conduit area. In this example, 3,125 square inches divided by 0.40 equals 7,8125 square inches. This means the conduit must have an internal area of at least 7,8125 square inches to accommodate the two service entrance cables while adhering to the NEC fill requirements. Fifthly, compare the required conduit area to the actual cross-sectional area of the conduit you are considering. A 2-inch conduit has a cross-sectional area of approximately 3.14 square inches. Since the required area of 7,8125 square inches is significantly larger than the available area of a 2-inch conduit, it is clear that the 2-inch conduit is not suitable for this application. Sixthly, select a conduit size that meets or exceeds the required area. In this case, you would need to choose a larger conduit size. Consult conduit manufacturer's data to determine the internal area of various conduit sizes. For example, a 3-inch conduit typically has an internal area greater than 7,8125 square inches and would therefore be a more appropriate choice. Always verify the specific dimensions with the conduit manufacturer to ensure compliance. Seventhly, consider the physical constraints of the installation. Ensure that there is sufficient space to install the larger conduit and that it does not create any obstructions or safety hazards. Also, check local amendments to the NEC, as some jurisdictions may have more stringent requirements. Eighthly, when installing service entrance cables and conduit, it's essential to use appropriate fittings and connectors that are rated for use for service entrance cable and the specific type of conduit being used. These fittings should provide a secure and watertight connection to prevent moisture from entering the conduit, which could damage the cables. Ninthly, remember that service entrance cables must be supported properly along their run. The NEC specifies the maximum intervals for cable supports, which vary depending on the cable size and type. Proper support prevents the cables from sagging or straining, which could lead to insulation damage or premature failure. Tenthly, grounding and bonding are crucial aspects of any electrical installation. Ensure that the service entrance cables are properly grounded and bonded according to the NEC requirements. This helps to minimize the risk of electric shock and provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse. 11thly, always consult with a qualified electrician or electrical inspector to ensure that your installation meets all applicable codes and standards. Electrical work can be dangerous, and it is important to have the work inspected to ensure that it is safe and compliant. In summary, You cannot run two service entrance cables, each servicing a 100 amps meter, in a single 2-inch conduit. The NEC requires that the conduit be sized based on the total cross-sectional area of the cables and the maximum fill percentage specified in Table 1. A 2-inch conduit is simply not large enough to accommodate two service entrance cables. While meeting these requirements, you must select a larger conduit size and ensure that the installation meets all other applicable codes and standards. When dealing with electrical installations, it is always best to err on the side of caution and consult with a qualified professional. They can help you determine the correct conduit size and ensure that the installation is safe and compliant. Furthermore, it is important to understand the difference between service entrance cable type SE and other types of cables that might be permitted to be installed in conduit at a higher percentage fill. Service entrance cable is specifically designed for bringing power from the utility service drop to the main service disconnect. It is constructed differently than other types of cables, such as THHN or XHHW, which are commonly used for branch circuits and feeders inside a building. Because of its construction and intended use, service entrance cable has stricter requirements for conduit fill. Other types of cables, such as THHN or XHHW, are typically installed as individual conductors within a conduit. This allows for better heat dissipation and makes it easier to pull the conductors through the conduit. As a result, the NEC allows for a higher percentage fill when using these types of conductors. For example, Table 1 in Chapter 9 of the NEC provides different fill percentages for various combinations of conductors and conduit types. It is important to consult this table carefully to ensure that you are using the correct fill percentage for your specific installation. Additionally, consider the dirtying factors that may apply when installing multiple conductors in a conduit. When multiple current-carrying conductors are installed in close proximity, the heat generated by each conductor can raise the overall temperature within the conduit. This can reduce the ampacity of the conductors, and it may be necessary to direct them to prevent overheating. NEC Table 310.15 provides adjustment factors for ampacity based on the number of current-carrying conductors in a raceway or cable. It is important to apply these adjustment factors to ensure that the conductors are not overloaded. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date with the latest requirements. The NEC is typically updated every 3 years, and it is important to use the most current edition of the code when designing and installing electrical systems. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. It is important to check with your local electrical inspector to ensure that your installation meets all applicable requirements. The local inspector can also provide guidance and answer any questions you may have about the code. When working with electricity, safety should always be your top priority. Wear appropriate personal protective equipment such as safety glasses and gloves, and be sure to energize circuits before working on them. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. They have the training and experience to safely and properly install electrical systems. In addition to the technical aspects of conduit fill and cable sizing, it is important to consider the overall design of the electrical system. The system should be designed to meet the current and future needs of the building, and it should be installed in a way that is safe and reliable. Consider the location of the service entrance, the size and type of service equipment, and the distribution of power throughout the building. It is also important to consider energy efficiency when designing an electrical system. Use energy-efficient lighting and appliances, and install controls to reduce energy consumption when it is not needed. A well-designed electrical system can save you money on your energy bills and reduce your environmental impact. Before starting any electrical work, it is important to obtain the necessary permits. Most jurisdictions require permits for electrical work, and it is important to comply with these requirements. The permit process ensures that the work is inspected and that it meets all applicable codes and standards. The inspection process helps to ensure that the installation is safe and reliable. It is also important to keep accurate records of all electrical work that is performed. These records should include the date of the work, the materials used, and the results of any tests or inspections. These records can be helpful for future maintenance or repairs. Maintaining accurate records can also help to protect you from liability if there are any problems with the electrical system in the future. In conclusion, running two service entrance cables in a single 2-inch conduit is not permitted by the NEC. The code requires that the conduit be sized based on the total cross-sectional area of the cables and the maximum fill percentage specified in Table 1. A 2-inch conduit is simply not large enough to accommodate two service entrance cables while meeting these requirements. You must select a larger conduit size and ensure that the installation meets all other applicable codes and standards. Always consult with a qualified electrician or electrical inspector to ensure that your installation is safe and compliant. This explanation covers the code requirements, calculations, and practical considerations involved in running service entrance cables and conduit. Always prioritize safety and compliance when working with electricity.